Now that we know how to get a data set, how to clean it up, remove the bad entries in the data set, the next step is to split the data set. So dataset splitting is a way to validate the performance of the model. Suppose if we have the dataset and if we use the entire dataset for training, we don't have something to validate it against, right? So what we could do is we could split that dataset into a part which is used for training and use a part for just testing. And this is a very good way of splitting a dataset to evaluate the performance. But the thing is, if we want to do some hyperparameter tuning, which we'll be doing towards the end of this course, we would need another chunk of it, which is called valid dataset, so that the test dataset is never seen by the ML model during training. And this type of a split is what is recommended for training machine learning models. We'll see how to do this split using some of the packages that are available in Python. What we need to note here is when we have a split which is train, valid, and test, we would need to have similar distributions in training, valid, and test datasets. For instance, if we have a classification problem where we need to classify a molecule as active or inactive, we cannot just have the training dataset with all active molecules and all inactive molecules in the test or valid dataset. We need some equal distribution of that. And there are ways to do this, and this is what we'll explore in this lesson. Splitting datasets. So once we have cleaned up the dataset, we can split into training, validation, and test splits. And as I mentioned, there are libraries to do it. And one way to do it is just to look at the values, as I mentioned earlier. Look at whether it's active, inactive, and make sure that it's evenly distributed. Or even you can look at the input distribution, like the molecule having molecular weights in a range are equally distributed, or you can make sure the scaffolds are equally distributed, meaning similar types of molecules are there throughout the dataset. And we can do it with the smiles, and we'll see how to do it. And in this example over here, we'll do it on the QM9 dataset that we have, and we'll use the HOMO-LUMO gap as the target. As before, we import the libraries, the pandas, and read the dataset directly from the URL, and we look at the top 5 entries as before. Now what we'll do is we'll split the dataset, and there are various packages which can be used. Here we'll use FastML, which is a package to analyze datasets, but it's not chemistry aware, so we would not be able to split it based on molecules, like similar molecules in all dataset. This is just a random split of the dataset into into training, validation, and test datasets. And at first, let's install FastML. Once this is installed, you'll get the message that successfully installed FastML. And the train, valid, test split is a function in model development in FastML. So let's import that function. And once it is imported, we can start splitting. One way of splitting is let's say test, valid, and train, valid, and test. We split them in 80% of valid, 10% of 80% of train, 10% of valid, 10% of test. And once we split it, we can get the x's and y separate. So remember, y is the target or the HOMO-LUMO gap that we want to predict, and x is the input. And in this case, we have smiles input, right? So we have smiles in the data set, so we'll just use smiles and gap as the data set, and the target is gap, and we use a Twain size of 0.8. That's 80% of this data set would be training, and 10% for valid, and 10% for test. Once we run this should split it into the corresponding x and y's for train, valid, and test. We can look at one chunk of it. It's the test one, and we see that x is the smiles first. So we have a list, a data frame of smiles, and we have around 13,000 of those. And the original data set has around 134,000 entries, and we see that this is 10% of the data set. Similar with the y values, we can look at the y values here, and these are the y values for the data set. Now we can move into something more chemistry aware, though the above method can be used for all data sets. But if you think that your data set is more chemistry aware and there are some molecules not evenly distributed throughout, and you wanted to make sure that the molecules are evenly split, in that case we can use splitting Python packages, which something like DeepChem, and there are other packages which you can look up, but over here we'll use DeepChem, and we use molecular weight for splitting it, and we'll make sure that molecular weight is evenly distributed in the data sets. So we'll install DeepChem, and pip install does the installation for DeepChem. Once it's installed, it will install a bunch of packages which include SciPy and other things. We'll see how that comes out. And once it says restart one time, you would need to do that sometimes, and let's say we'll just restart one time once we install these packages, and it'll show you initializing. Now it's ready to run. So first import DeepChem as DC. We'll import this package, and we will make sure that it is imported. If this is not imported, I would suggest you running the previous cell, or click on the restart one time again and run this again. Once we have that, we can now read the pandas data frame again, because we restarted the kernel, and that deletes all the variables and everything that we read. So let's just read them again. We have smiles as the input, right? So what we can do is we use the smiles and create the molecular weight distribution. But before we do that, some of these packages which are meant for deep learning use specific format for the datasets. Over here we have been using a CSV file and a pandas data frame to do this. But in some cases, like in DeepChem, we need to load that dataset into a object called NumPy dataset. So we can do that with this function, but it will load the data frame from data frame or function on the NumPy dataset will load the data frame. So we can pass the data frame, which is smiles and gap, with x as the smiles and y is the gap. And IDs is required because this is what it will operate on to split the data sets later. So let's say IDs is equal to smiles. Make sure that this is set to smiles, and click on the play button. This should transform the data frame that we have into a data set, which is specific for DeepChem, which is called NumPy dataset. If you are using some other Python packages to do this, you will be required sometimes to convert your pandas data frame into that specific dataset object. And you can look into the documentation of how it's done. So now we can look at the y values, and these are all the y values in the dataset. You can also look at the x values, and these are all the x values, C, and this is what we saw before, like all these molecules, the smiles for these molecules. Now we can perform the split, as we have the dataset transformed into a DeepChem dataset. And the way we would do it is using a molecular weight splitter. And molecular weight splitter is a type of splitter available in DeepChem. You can look at other splitting methods available in DeepChem using this link over here. And there's documentation of how to use those classes of molecular data splitting. Over here we use molecular weight splitter. So first thing is to create a molecular weight splitter object, and we use deepchem.splits as molecular weight splitter. So we'll create this object at first, and once we have created that object, we can use it to split it. The format is something like this. This is the molecular weight splitter object that we created, and then this is the method that we are going to use. It's called train valid test split. And the input for this method is the dataset that we have, and fraction of train, let's say 80%, 0.8, fraction of valid, 0.1, 10%, and fraction test is 10%. So the output from this method is a tuple, which is a train dataset, valid dataset, and test dataset. It automatically splits it into these, and these objects in turn, train dataset, valid dataset, and test datasets, are again a NumPy dataset type. So once we run this, it'll take a while to split it, and once it's split, we can look at what the datasets look like, and they should be again an array of x and y's to do it. So we can also convert these back to data frame, so that if we are comfortable with data frame and managing data frames, it's better to convert them back. And the way to convert them back is using the toDataFrame method. And we have train dataset, toDataFrame will give us train dataset, valid dataset, toDataFrame will give us a valid dataset, and test dataset, toDataFrame will give us the corresponding one. And once we run that, we can see again the test dataset and has 10% of the data as before. But if you look at the distribution of molecular weight, which we are not doing here, we'll just assume that it's split based on molecular weight. Just as an exercise, you can look at molecular weight of each of these and plot them for test dataset, valid dataset, and train dataset, and see whether the distributions of molecular weight is similar. And you can compare that with the random split of the dataset and see whether the random split is a better method to split the data, or whether the molecular weight splitter was a good option to do it.